let's say that this is you. You're enjoying a nice sunny day and you decide to take a nice, long, deep breath of air. And of course, when I say air, the part that you probably care the most about is just the oxygen part of that air, right? That's the part that we as humans need to survive. So you take a deep breath, and let's say that you take it through your mouth. You take a deep breath through your mouth. And then let's say you take one more deep breath, a second deep breath, and you take that one through your nose. Now you might think, well, these are two totally different ways of getting in air, right? That's certainly how it looks when you look at a mouth and a nose. It doesn't look like they have much in common. But the truth is that actually if you follow the air, it almost follows an identical path, right? So the air is going to go into the back of the throat, really regardless of how you took it in. So here we have air coming in from the nose, and here you have air coming in from the mouth. And they meet up in the back of the throat. And then they go down, down, down. They go towards this thing that we call the Adam's apple. I'm going to bring up a little bit of the canvas so you can see it more easily. But basically you bring up this, or you see this Adam's apple right here. And actually you can go ahead and take a feel of your own Adam's apple. It's a pretty cool structure in the middle of your throat, and everybody has it. That's the first thing I want to tell you, is that everybody has it, not just men. Women have it too. And the reason it's called an Adam's apple, it's called an Adam's apple because Adam is a generally a boy's name, and so it's to remind us that usually men or boys have larger Adam's apples than girls. And if you're trying to find it, I just also want to point out there's this notch here. And if you can feel the notch with your fingers, that gives you a nice clue as to where it's located. But this is it. This is the Adam's apple. And what it does is it helps you control your voice. And actually another name for the Adam's apple, another name for it is sometimes people call it the voice box. The voice box. And of course, air is passing through the voice box. And it's kind of the entryway into the trachea. And so it actually allows me to make my voice really high or make my voice very low, depending on how you change the muscles around in that Adam's apple. So that's actually the kind of first cool thing I want to point out to you, is that you can actually control your voice. I'm sure you knew this already, but what you're using is your Adam's apple or your voice box. Now, air keeps going, right? Air is just going to keep making its journey down, and specifically, of course, the part of air I said we care about is the oxygen. It's going to keep making its journey down into the lung area. So this is now the lung area. It's gone down the trachea and it goes into the two lungs, the right and left lung. This is the left lung. I'm going to put L for left, and this is the right lung. I'll put R for right. And immediately you're thinking, well, wait a second, aren't they switched? Now I want you to remember that this is from the perspective of the person who owns the lungs. So that's why I'm putting left where I put it and right where I put it. Now, we should probably go ahead and start labeling some of this. You can see that the lungs actually don't look identical, right? They look slightly different. For example, this one has 3 lobes. The right side has 3 lobes. We call it the upper lobe, middle lobe, and lower lobe. And the left one only has 2 lobes. So that's the first kind of big difference. And the other difference is that you actually have this thing in the middle that we call a cardiac notch. This thing right here. This is called the cardiac notch. And the reason we call it that is that it's a little spot that gets formed because the heart is literally kind of peeking out here. And as a result, it kind of makes a notch in the lungs when it develops. So the heart takes up a little bit of space here. This is our heart. And as a result, it takes or makes that notch. So this is our heart space here. So on the other side, you've got, of course, your 2 lobes, your upper and lower lobe. And these are 2 clues. So if you ever see a lung just kind of sitting by itself and you want to figure out whether it's the left lung or the right lung, you can look for the lobes, the number of lobes, or you can look for that cardiac notch. Now, around here, around these lungs, you've got ribs, right? So you've got ribs here, and between the ribs, you've got rib muscles, and they're, of course, on both sides. And below the lungs and below the heart, you've got a muscle, a big muscle. Actually, it's going to come through here, I'm going to just kind of go through the word heart, and it basically becomes the floor. So the heart and the two lungs, they sit on this floor made up of this muscle, and this muscle is the diaphragm muscle. So this diaphragm muscle makes up the floor. The ribs make up the walls. So what do we have? We have basically a room. We have a giant room with walls and a floor, and this entire room we actually call the thorax. So within this room, then you have your two lungs and your heart. So far so good, but I haven't done a very nice job of actually showing you where the air goes. I've just kind of pointed that it goes to the two lungs, but you don't actually get to see where it goes after that. So I'm going to erase a lot of this. I'm going to reveal to you what it would look like if you could slip on some X-ray glasses and look at your two lungs. This is kind of what it would look like, right? You've got all of this interesting architecture. And the easiest way to kind of think about this, probably the simplest way to think about this, is to imagine a tree. So imagine a tree, and that tree has been flipped upside down. So you've got all these branches off that tree, and they're branching and branching. And if you flip this tree upside down, you start seeing that it looks a lot like what we have in our lungs. Our lungs basically look like a flipped upside down tree. And we even call it that. We even call this entire structure, we call it a bronchial tree. So when you look at the lungs and they look kind of messy or complicated, just think of them as an upside down bronchial tree, and all of a sudden it'll look much simpler. With basically in the middle, you've got this nice trunk, right? This is our trunk, and then it starts kind of branching from there. So air goes down this main trunk, this trachea, and then it kind of starts splitting up. And each of these kind of colored regions, the green region or the purple region, serves a different lobe. So this green region serves the lower lobe down here. The purple serves the upper lobe. And on this side, you've got an upper, a middle, and a lower lobe. Now, I know it looks a little bit strange because you've got some green branches in what should be the middle lobe, like right here. You've got some orange branches in what looks like the upper lobe, like right there. But what you have to remember, and this is kind of tricky to do, and just try to play with it in your head, what you have to remember is that what you have is basically a three-dimensional lung. So you have to imagine that we're only looking at it from the front side, but of course that middle lobe does go back. And if it went back, then you'd make perfect sense why the orange branches are where they're at. Now let me continue the air journey because I want to make sure we finish it off. So let's say we take a little branch like this, right? We expand it, we keep, going, zooming into it until it's microscopic. You can't see it with your eyes anymore, but you could see it under a microscope. It would look like this. It would basically, under a microscope, it would look like a bunch of little sacs, like this. And these sacs, we call these alveoli. And the air actually kind of runs into the alveoli. It has a dead end, and then it comes back around. And then you breathe it out. So that's how breathing works. The air goes all the way in from your mouth down to the alveoli, takes a U-turn, and then goes back out. But before it does that, before it leaves, very close to the alveoli is blood. And let's say blood is coming this way and going that way. And what will happen is that actually out of or into the blood, let's do that first, will go oxygen. Oxygen will actually go into the blood. And out of the blood will be waste. So you'll have some carbon dioxide waste that your cells have been making. And that waste actually then gets thrown back into the alveoli. So now you can see how oxygen gets from the outside world, gets breathed in through the lungs when you inhale, gets down into the alveoli, exchanges with the blood, and then you exhale and let all that carbon dioxide out.